Hello everyone, hope you all are doing well. So today we are going to discuss paper 2's topic 74B, that is the remaining parts of pesticides, their formulation, mode of action, etc. So the first topic we are going to discuss today is phytoalexins. So phytoalexins are defined as low molecular weight antimicrobial. These are defined as low molecular weight antimicrobial compounds that are both synthesized and accumulated in plants. These are both synthesized and accumulated in plants after exposure to microorganism or aquatic agents. After exposure to microorganisms or abiotic agents. So this was what phytoalexins are. Now concept of phytoalexins. It was given by this concept was given by Muller and Borger, Borger. So number 1, phytoalexin is formed only when the host cells comes into contact with parasite. This phytoalexin form only when host cells come into contact with parasite, and this is a kind of defense reaction. Number 2, defense reaction. That occurs only in living cell. Number 3rd concept, the inhibitory material IM, that is inhibitory material, inhibits, is a chemical substance. Inhibitory material is a chemical substance and may be regarded as product of necrobiosis of host cell, and may be regarded as product of necrobiosis of host cell. Number 4, phytoalexin is non-specific in its toxicity. Phytoalexin is non-specific in its toxicity. Resistant state is not inherited, and the resistant state is not inherited. The defense reaction is confined to tissue colonized by fungus and its immediate neighborhood. The defense action is confined to tissue colonized by fungus and its immediate neighborhoods. That is immediate types of immediate of the fungus neighborhoods. Now what are its chemical nature? What is its chemical nature of phytoalexins? Chemical nature of phytoalexins. Chemical nature. First of all, it is a broad spectrum inhibitors. Fall in several classes including terpenoids, glycosteroids, alkaloids, etc. Its derivatives are simple phenyl pronoid pathway, phenyl pronoid pathway, ischemic acid pathway, next one is TRP pathway, mevalonic pathway. So these are its derivatives. Moving on, derived from one or more primary biosynthetic pathway. It is derived from one or more primary biosynthetic pathway such as capsidol, MPA, picetin. It is ischemic A and acetate melanoate pathway. It is diverse in chemical structure, produced by many families. It's diverse in chemical structure that is produced by many families. Let me rub. It is used to examine chemotaxonomic relationship. Can we use to examine chemotaxonomic relationship. Number 7, associated with hypersensitive reaction. Hypersensitive reaction. Number 8, observed after a few hours to days following infection. Observed after few hours to days following infection by species of plant pathogen. Following infection by plant pathogen. So this was the chemical nature of phytoalexins. Now moving on to the next topic, that is pesticide resistance. Pesticide resistance. It describes the decreased susceptibility of a pest population. It is described as decreased susceptibility of a pest population to a pesticide that was previously effective at controlling the pest. This was previously effective. So the pesticides which are previously effective in controlling the pest is now not that effective. Decreased susceptibility, that is, the pests have become resistant to the pesticides. What happens here? Pest species evolve pesticide resistance via natural selection. Pest species evolve pesticide resistance via natural selection. The most resistant specimens, that is more natural selection of the most resistant specimens survive and pass their acquired. The most resistant specimens survive. The most resistant ones survive, and they pass their acquired heritable changes traits. When they pass their changes, acquired heritable changes to their offsprings. So this way the whole population becomes resistant. For example, you can write here fruit flies resistance to malathion. We all know malathion is a very popular pesticide. So now there are two types of resistance, that is single or cross resistance or multiple resistance. We will also discuss vertical and specific resistance, but this is different one. Single slash cross resistance and multiple resistance. Type of resistance in which a pest population develops resistance to more than one pesticides within a chemical family. Here the resistance is against one pesticide within a one or more than one pesticide within a chemical family. Example you can give of organo, that is resistant. Some pesticides are pests have become resistant of a organo phosphate insecticides. This family of pesticides are not be able to control that now. Now what is multiple resistance? It involves multiple independent resistance mechanism which often leads to resistance to chemicals from different families. Here it is the resistance against chemicals of different families. Here one or more chemical within a family, but here different families. Example, one pest can be resistant from both organophosphate and carbamate families, carbamate insecticides. So here resistance from different families and resistance from one family only. So this is the difference between single cross resistance or single or cross resistance and multiple resistance. So I hope you understand this. Now moving on, the next topic, that is management of pesticide resistance. How will you manage this pesticide resistance? So we will apply pesticides only when needed, not unnecessary. Unnecessary use should be regulated only when needed. For this we could scout fields to determine pest population. We should scout fields, look into our fields to determine pest population. We can use thresholds. We can use pesticides only when thresholds are met. That are, these pests are now giving more damage. We have discussed thresholds in detail in previous lectures. You must see it. We should follow label directions. How to use, how much quantity should be used, should be followed. Rotation of pesticides from year to year and during year. We need to rotate our pesticides. Only one pesticides when it is used year after year. The pest develop a resistance against it, but when it will be rotated, the chances of resistance will be low. We can use alternative management options. Such as tillage, natural enemies, crop resistance, crop rotation, etc. Resistant pest can develop using other management techniques also, and these can be managed using other management techniques, such as use of varieties that are resistant to this pest, so that we don't need to use pesticide. So this is how we can manage pesticide resistance. Now moving on to next topic, that is vertical or specific resistance. So we will discuss vertical and horizontal resistance. So first of all, what is vertical or specific resistance? So a specific resistance of a host to a particular race of pathogen is known as vertical resistance. A specific resistance of host to a particular race of pathogen, to particular family's race of pathogen. This is known as vertical resistance. It is governed by one or few genes. That is, it is oleogenic. resistance, and usually short-lived and less durable. And it is only resistance that is short-lived and less durable. That is, it can be break down when new race of pathogen is formed. Particular race of pathogen, when new race of pathogen comes, these resistance breakdowns because it is affected towards a particular race, not new races. It displays discontinuous variation among genotypes. It displays discontinuous variations among genotypes. And classification of genotypes into resistant substitute possible. And here we can classify genotypes on basis of resistant and substitutable. This is possible. The particular race of pathogen it is resistant, so it will be classified as resistance. Particular race is substitutable, it can be classified as substitutable. So this is it. It has high heritability and can be easily identified in integrating programs. It has high heritability, so it can be easily identified in breeding programs. So this was about vertical resistance. Now what is horizontal resistance? Sometimes they also ask difference between the two. You should know it. Now what is horizontal resistance? Horizontal or general resistance. It was specific. The before one is specific. It is horizontal or general resistance. It is resistance to host of all races of pathogen. Resistance to all races of pathogen. Here it is a polygenic resistance. The previous one was oleogenic resistance. It is polygenic resistance, that is controlled by number of genes, many genes, also known as quantitative resistance. Minor gene resistance, as each gene involved in resistance has a small effect which is not visible. It is also known as minor gene resistance. In the previous one, the gene resistance was visible, we were able to classify, but here each gene has a small effect. Each gene has a small effect, so which is we are not able to classify. It is not visible. These small effects are not visible. So this was horizontal resistance. I hope you all understood these things. So that is all for today. Hope you understand the topics very well. So for any queries, do comment. If you like it, please press the like button. Do share and subscribe. Keep making notes. That's all for today. Have a nice day. Thank you.